Thank you, Sean. Thank you for the invitation. These are my disclosures. I won't be talking about any of them. The purpose of this talk is I'm going to try to keep it as practical and clinically relevant as possible. This is not going to be a talk on the technical nuances of machine learning. It's to show you just an appreciation of what we can do with machine learning and AI and some of the early prototypes for safe cholecystectomy and what are some of the barriers. So what is AI? It's obviously it's a buzzword now. It's permeated every facet of society. It's a study of computer science that gives algorithms the ability to perform high-level functions like humans, perceptual functions, decision-making functions, and a variety of other things. And there's a lot of things out there. The field has completely exploded over the last 10 years. Everybody knows about large language models, ChatGPT. It can help you write manuscripts to writing a song in the style of Taylor Swift and about surgical AI. So there's a lot that it can do. We've heard about deep fakes. You can record videos of yourself and put whatever filter you want and make it look like that. There's algorithms that'll take your voice and then simulate that. So the technology's gone scary good. There's also algorithms that generative AI has become extremely popular. You can put in a prompt and it'll create videos that never existed before. So the field has advanced quite a lot. One area that AI has been very successful in is in an area called computer vision. The ability of AI algorithms to be able to identify or make sense of data that has pixels in it, basically images and videos. AI algorithms that can tell you, okay, in this frame, this is what I see, or this is where the object is located. And obviously the automobile industry has done a lot with this, so it can track images, objects, and so on. And so this is very attractive for surgery. If we're talking about developing AI algorithms for guiding us for difficult gallbladders, algorithms that can make sense of the surgical field and tell us where the anatomy is, where the safe areas of dissection are, and things like that. AI has become very popular in medicine. Various subspecialties have embraced it. Field of radiology has come a long way. Radiomics, genomics, pathology, cardiology, neurology, all these fields have used AI in a number of different ways. And surgery is kind of lagging behind. Before we talk about surgery, I think it's really important to really understand what's the unmet need. I think the one thing I want to emphasize with AI is obviously it's a very revolutionary technology, but it's not good to kind of say, okay, AI is good, let's use it for surgery. That's a wrong approach. It's guaranteed to fail. I think it's important to understand what are the problems and then design the solution to address that problem. And so the area that I've been really investigating in our lab and our work has been how to improve surgical performance. To perform an operation safely and effectively, there's an entire myriad of skill set that are required that you need to exercise during an operation. And there's a lot of data that suggests that adverse events, bile duct injuries, not only are they a lot of them preventable, but you can trace it back into the operating room. Usually it's like an error in decision making or judgment, high level cognitive processes. It's not because you had a shaky hand that injured the bile duct. It's usually you're dissecting in a wrong plane, you don't have the proper exposure, you divide a structure without getting a critical view of safety, and so on. So you can actually map all that out. This is for adrenalectomy, but there's a lot of cognitive processes that take place during a surgery. So critical view of safety is just one of many things. Knowing where the line of safety is just one of many things. The key is to understand where do errors occur and then design solutions that can provide us with guidance and support and really augment our abilities like AI during the surgery. So what are some of the early prototypes? This is some of our early work. You may be familiar with this. We said, okay, can we train an AI algorithm to do something very clinically practical, very relevant for someone doing a lap chole, so identifying safe zones and dangerous zones of dissection relative to this line of safety. And it's not, the thing that's really different about that, you're not doing an algorithm that can define an object that's clearly delineated. It doesn't have clear boundaries. It's sort of like a generalized area that you know is safe. So can you train an AI to do that? And I won't go through all the nuances of the methodology, but we took basically hundreds of videos and we asked expert surgeons to annotate them. And so we said, okay, AI, here's hundreds of examples of go zones, safe zones of dissection, and examples of unsafe areas of dissection, and we were able to train an algorithm to do that. This is what the AI looks like. This is a video it has never seen before, and that's, and it's able to make inferences on that lap chole. It's able to say the safe area is in green, the unsafe area is in red, and frame by frame provide that analysis. And so suddenly we are able to sort of project our mental model on the surgical field, which is something that we've never been able to do before. And you can see this really opens up a lot of possibilities, not just for real-time decision support, but also for things like assessment and coaching and video analysis. Oh, there we go. And we've come along since when this was kind of version 1. This is like the newer versions. So there's many ways to skin a cat. It's designing AI algorithms is not just step 1, step 2, step 3. There's an entire science devoted around choosing the proper algorithm that'll do what you want. And so this one on the right is like the latest one. It's called SegFormer, and it's basically very, very accurate. You see, it's very stable, the images, but it's also very computationally heavy. So you want to, you have something very accurate, but it's not very good for scalability. This one, on the other hand, it's a little bit more jittery, but it's not very computationally heavy, so it's good for scaling this. Obviously, we want improvement in outcomes, so how do you measure that? We can't really do clinical trials to see if bile duct injury is approved, so we assess the AI algorithm on videos of bile duct injuries. And so this is a video of a bile duct injury. You can see the AI algorithm is highlighting the go zone, the safe area. Unfortunately, they ended up dividing and clipping and dividing the common bile duct, and you can see the AI algorithm is recommending to suggest higher. Basically, we took dozens of video, and 50 to 80% of them, the recommendation could have potentially prevented bile duct injury. That doesn't mean that 50 to 80% of bile duct injuries would be prevented. That's just what the AI would have done. We've removed a human factor here. Whether or not somebody takes the recommendation, in real time is a completely different thing. AI can also tells you what it sees in the surgical field on a high level. So this is an algorithm developed by the group at Strasbourg at IHU. It assesses whether or not a critical view of safety has been achieved, and not only whether or not it's been achieved, but which element has been achieved or not. And there's a lot of groups around the world that have done this. And as you know, SAGES is launching the Critical View of Safety Challenge, which is basically a large data set where groups of computer scientists around the world are going to compete to design the best algorithm for that. Another important cognitive behavior is establishing good exposure and retraction of the gallbladder to really open up the hepatocystic triangle. It's something I spend a lot of time and energy to take my trainees through a case. So this is the work of one of my postdocs to train an algorithm that can help you with that. We've gamified this as well. We've turned it into a game app called LapBot. It's free. It's available. The residents love this. You basically gives you scenarios, and then it gives you accuracy scores, and every level corresponds to a Parkland score, and it gives you some feedback as well. And there's a leaderboard too. Finally, I want to finish off by talking a few challenges that are really important. There's a lot of challenges. AI is really cool and exciting, but there's a lot of problems. Number one, we don't actually have good metrics for computer vision algorithms. The traditional metrics we use are these mathematical metrics that don't have a lot of clinical relevance. So you can have a model that looks good on paper, but the moment you run it on an actual video, it's not very clinically relevant. A lot of models lack breadth of data, generalizability, the ability to tell you why it made a prediction, and for all the hype around AI, we don't actually have a lot of outcome data to say whether this actually improves what we do. And probably one of the biggest challenges is we have a major implementation problem. Scaling this, like you can have, let's say for the sake of argument, the best AI algorithm that gets published tomorrow. How do you get that into your operating room to use it on a patient? We haven't really figured out how to do that. So a lot of our work has been around developing a machine learning pipeline to get that into your operating room. So you can actually collect a video stream, with your with your tablet, with your phone, or even connect it to your laptop and get AI inference in your OR. Another one is this sort of shoebox that you look and think with a GPU in it, where you plug and play into your operating room. And then lastly, we have to consider design issues as well. How do end users actually want that in their operating room? Do you want a heat map? Do you want probabilities? Do you want a green or red? Do you want to adjust the probability threshold? So only give me a recommendation if you're 90% sure. All of these are design features that we haven't even begun to touch. So in summary, AI is a very powerful tool for improving surgical care, and LabColi has been really the test bed for a lot of this technology. The technology is really in its infancy, but there are a lot of low-hanging fruits as well. But it's really important to realize that there's many, many obstacles, and we still have a very long way to go. I want to acknowledge all those in my lab and all my collaborators, and again, thank you for the honor.